Not too many people have dipole antennas anymore, so the context of this passage may not be as necessarily relevant to people, but that isn't really that important. We're just looking at the picture and doing some geometry. So we know that z is the base of the angle, and that points x and y are tangent on these wires. And so how far point x is from the center of the loop of wire, I'll change colors here, is actually just going to be the radius of the circle. So if we can find out anything at all about the circle, we can usually get to its radius. Let's take a look at the statements. Statement 1 tells us that the perimeter of the loop of wire is 3 feet. Remember that the perimeter of a circle is equal to 2 times pi times the radius. So 2 pi r equals 3. And from there, we can divide both sides by 2 and pi, so r equals 3 over 2 pi. That's the radius, and that's our answer. So statement 1 is sufficient. We can get rid of 2 on its own, as well as the 2 insufficient statements. Statement 2 tells us the center of the circular loop of wire is 2 feet from point Z. So knowing that this distance is 2 is not quite as helpful, because while we know this distance, and that is enough for us, that forms the hypotenuse of a right triangle. If we were to draw another radius to point y, that becomes a right triangle. But without at least one more side, we can't use the Pythagorean theorem to find the radius. Nor do we have the angle measures other than the 90-degree angle, so we can't use the special properties of 30, 60, 90 triangles or 45, 45, 90 triangles. So on its own, knowing that distance is insufficient, we cross off D and select A.